Okay, in this video we're going to find the inverse of a 3 by 3 matrix here. And so what we're going to do here is on this 3 by 3 example, I'm going to take this matrix and I'm going to augment it with the 3 by 3 identity matrix. Okay. So here's the matrix A. So you can see here's the matrix A right here. And I'm going to take that matrix and I'm going to augment it with the 3 by 3 identity matrix. I have to use the 3 by 3 in this case since I've got a 3 by 3 matrix that I'm trying to find the inverse of. Okay, so now this one actually is not too bad because when we start here, notice we already have a 1 right here, and now I want to use that 1 to get rid of these guys. Remember, I want this to look like 1 0 0 0 1 0 and 0 0 1 when I'm finished. So I want to get rid of these guys here. Well, this is pretty easy to do. Just take row 1 and add it to row 2 to cancel the negative 1. So 1 plus negative 1 is 0. Negative 3 plus 4 is 1. 7 plus negative 7 is 0. 1 plus 0 is 1. 0 plus 1 is 1. And then 0 plus 0 is 0. And then to get rid of this negative 1, I've got to do row 1 plus row 3. So similar operation. 1 plus negative 1 is 0. Negative 3 plus 3 is 0. 7 plus negative 6 is 1. 1 plus 0 is 1. 0 plus 0 is 0, and then 0 plus 1 is 1. Okay, so now I have this matrix, and I just went ahead and copied this down here. So if you let's just move down here. So I copied the matrix down here. And now remember what you want to do now, once you get the 1 here and the zeros below it, go ahead and go to the next row and make this second row, second column entry a 1. Well, it's already a 1, so that's the good news there. We don't have to do anything. Now, I need to eliminate this negative 3 that's above it, so I can multiply this row by 3 and then add it to this to cancel the negative 3. So we're just going to do 3 times row 2 plus row 1 and put that in row 1. Well, 3 times 0 plus 1 would give me 1. 3 times 1 is 3 plus negative 3, that's going to give me 0. 3 times 0 is 0 plus 7 is going to give me 7. 3 times 1 is 3 plus 1 is going to give me 4. 3 times 1 is 3 plus 0 is going to give me 3. And then 3 times 0 plus 0 is going to give me 0. And the good news is I don't have to do anything to eliminate the number below the 1 because that number is already a 0. So now I'm at this step and I need a 1 right here. Now I'm just going to go ahead and copy this matrix down here so you can easily see the next row operation. So I've got a 1 right here and I want to eliminate the 7. Now notice I've already got a 0 here, so I don't have to eliminate anything there, but I do have to eliminate the 7. So I need to multiply row 3 by negative 7 and add it to row 1 so that it'll get rid of the 7. So negative 7 times 0 is 0, and then add that to 1, I'll get 1. And then negative 7 times 0 added to 0 gives me 0. Then negative 7 times 1 is negative 7, added to 7 gives me 0. Then negative 7 times 1 is negative 7, negative 7 plus 4 gives me negative 3. Then negative 7 times 0 is 0, and 0 plus 3 gives me 3. And then negative 7 times 1 gives me negative 7. Negative 7 plus 0 gives me negative 7. And now notice that on this side I have the identity matrix. See? So there I have the identity matrix I. So that means that this over here on the other side of the augment must be the inverse. So the inverse matrix is just the matrix negative 3, 3, negative 7, 1, 1, 0, 1, 0, 1. And you can check it yourself. Okay, here's another example and I'll go ahead and show you this one real quick. Again, just take the matrix and augment it with the 3 by 3 identity here. So notice I augmented it with the 3 by 3 identity, and then here I've got a 1 already there, and I've got a 0 here already, so I have to multiply this row by -2 and add it to this row. I'm going to assume that you know how to do the row operations now, so I'm just going to direct you on the row operations you need to do. So if you multiply row 1 by -2 and add it to row 3, your new row 3 should be this. Okay, now I have a 1 and a 0 and a 0. So now I want to move to the second row, second column entry, and I need this to be a 1. So to do that, I'm going to multiply row 2 by 1/2. And so I'll do 1/2 row 2 in row 2. So now if I multiply everything in row 2 by 1/2, that'll make this a 1. And then once I get the 1, I want to eliminate the -1 that's above it. So I can do that by just adding row 2 to row 1. So if you add, 0 to 1, 1 to -1, -1/2 to 1, 0 to 1, 1/2 to 0, and 0 to 0, it should give you this as your new row. And then I want to eliminate the 5 that's below it. So I'm going to have to multiply this row by -5 and add it to this row. So if you multiply 0 by -5, add it to 0, 1 times -5, add it to 5, -1/2 times -5, add it to -2, 0 times -5, add it to -2, 1/2 times -5, added to 0, 0 times -5, added to 1, it should give you this for your new row. Okay, so now I've got the 1 and the 0 above it and the 0 below it in the second column. Now let's move over to the third row, third column entry, and we want this to be a 1. So to make this a 1, just multiply everything in this row by 2, and when you do that, it'll give you the 1 right here. And then I need to multiply this row by -1/2 and add it to row 1 so that it'll cancel the half. So multiply everything in this row by -1/2 and then add the results to everything in row 1, and it should give you this for your new row 1. And then to get rid of the -1/2 here, I need to multiply row 3 by +1/2 and add it to row 2. So multiply everything in row 3 by +1/2, then add those entries to everything in row 2, and that should give you this for row 2. And once you do those operations, you're finished, because notice on the left here, there's my 3 by 3 identity. So the inverse must be this guy here on the right. So that's the inverse of your 3 by 3 matrix. Okay, now you can expand this to larger 4 by 4, 5 by 5 matrices to find inverses, but obviously I'm not going to do that, especially doing it by hand would take a long time. So we'll just stick to, we won't get any larger than 3 by 3 matrices to find the inverse of. Now to finish up this chapter, I still need to talk about a couple more things. So I'm going to talk about some interesting applications of the inverse of a matrix in the next chapter or next video.